Today we're joined by Christian Luhmann. He's a professor in cognitive science, psychology.
Correct, both.
At Stony Brook University, and has been very active in the community aspect of PyMC. Thanks for all the community efforts you're doing.
You're welcome.
I'm curious how you became a Bayesian. What was the most appealing thing where you're like, oh, well, this is actually a great way to, well, solve the problems you're facing?
Yep. I think I had always worked with relatively sort of complicated models that were sort of mechanistic in nature. And so they had a lot of sort of nonlinearities, and they were all sort of grounded in sort of reality in some sense. And so normal estimation techniques, ordinary least squares or whatever, don't really work. And so you end up doing optimization. And so I was already very comfortable with this notion of sort of building a model that reflects your understanding of where your data comes from. So that was already kind of in my head. And I'd been doing it and sort of doing optimization, and so getting sort of point estimates about sort of the answer. And I'd also been doing a lot of statistics, right, dealing with sort of scientific data. And I had never really kind of put the two together. I'd never really sort of related these or compared approaches or anything. And then at some point I was dealing with statistical models that got a little bit more complicated. They were specifically sort of multi-level models where you have sort of nested data. And I knew that there were techniques out there. I had sort of bumped into multi-level models before, and I had sort of read through the equations that you find in textbooks. And I had always sort of gone through the sort of bucket of subscripts that you always encounter to try and figure out that this specification links to that level. But I could never, it never kind of stuck, and it was not particularly intuitive to me. And someone very briefly in a hallway one day explained to me kind of the Bayesian approach to doing multi-level modeling or hierarchical modeling. And they basically said, oh, there's sort of a distribution, and then sort of each sort of category or instance or group or whatever is just kind of a draw from that distribution, and they're each a different draw. And I was like, well, that seems, entirely straightforward, very intuitive. And so that was kind of my entryway in. And then sort of, I think the thing that kept me was this kind of pervasive emphasis on the data generating process, right? That, in statistics, a lot of time you are using models, and you kind of understand the model, and there's a data generating process sort of behind the construction of that model, but oftentimes that's not how you arrived at that model. You sort of took it off the shelf because that's what you do in this particular situation. And the underlying data generating process or the assumptions about it might not actually sort of reflect your beliefs about the world or your data. And that slippage, was never super salient to me. But once I realized I could just sort of specify exactly how I thought my statistical quote unquote data worked, I was kind of hooked. And so there's a lot of things that people sort of proclaim to be kind of the advantages of Bayesian approaches, or what makes you sort of a true Bayesian, using Bayes' rule, distributions, all these things. And focus on the data generating process, I think, is something that people kind of in the Bayesian world take for granted and appreciate. But it doesn't seem, I think, from the outside like the most quote unquote Bayesian thing. But it's really what I ultimately like best about that approach to sort of dealing with data.
And then from there, how did you get to PyMC?
Well, I have been using Python for a long, long time, about 20 years.
Wow.
I think I started with Python like 2.2 or 2.3 something when I was given by my graduate advisor a brand new Mac, which was shipping with the then brand new OS X, right? Their sort of revolutionary new operating system, which is based on BSD. And so it just so happened to ship with Python. And so I was doing stuff with Python. And yeah, so I had been using Python. And so when I looked around for ways to do Bayesian data analysis, PyMC was sort of the obvious choice. And yeah, and there wasn't really any choice to be made. I just kind of hopped on that and kept using it.
What I always found interesting is, well, in general, what areas of the project different people are drawn to. You seem to be very drawn to the community, being very active on our discourse, the office hours,
Yep.
and helping people out. I'm curious what drives that particular aspect, and why do you feel like that is where you provide the most?
Yeah, I think the way that I sort of came to statistics and data analysis, and the way really that I came to modeling of all sorts, was pretty circuitous. It was pretty self-driven, self-taught. I didn't necessarily kind of sit through classes and then say, this is sort of what I'm doing now. And so I think I really appreciate in sort of all of the good and bad ways, this sort of intimidation and the learning curve and the kind of apprehension and the intimidation that kind of comes with any advanced technique, but sort of any data analysis, Bayesian data analysis. And so, yeah, and so I feel like I have sort of walked people through the path from like curious to like actually doing the thing. And I just find it very fulfilling. And I feel like there's a lot of the intimidation is sort of reputational, or it's sort of based on kind of faulty assumptions. And so I feel like, you know, just guiding people through and showing people that it's not that scary, it's not that complicated. It's in many ways much more intuitive than what they're sort of doing day to day. Yeah, I just find very fulfilling. I also, you know, I'm always sort of interested in learning new things, and you very often find that by trying to help other people, you learn a lot in the process. So that's also definitely part of it. But yeah, I think really just kind of the fulfillment of helping people out and sort of showing people the stuff that you're enthusiastic about and getting them enthusiastic about the same stuff is a big part of it.
So then you've seen and went through yourself that learning trajectory from just getting your bearings and then becoming very proficient at modeling yourself. And is there something where you see maybe a gap or something that newcomers or more advanced people would really have a lot of value in knowing, right, in terms of like moving fast along that trajectory, right? Because like you see the stumbling blocks every day of people. Yeah, like in terms of what they can do.
I mean, I think it's pretty sort of well understood for people who have already sort of made that journey that there's just a lot to know. Once you get into sort of Bayesian data analysis, you are doing statistics, and then you're kind of not doing sort of conventional statistics necessarily, because you can kind of break down these barriers and not just do kind of the ordinary kinds of things, linear regression or whatever. You can really describe kind of whatever you want, and that is freeing, but it's also sort of complicated because you have a lot of choices. It is sort of computer programming, and there's a whole bunch of kind of math, not about the modeling, but about the sort of inference process, the sampling process. There's packages and libraries and compiler, and like there's this sort of never-ending list of stuff that one could know about that's kind of in the sphere of Bayesian data analysis. And so, yeah, there's a lot, and I totally understand when people are kind of overwhelmed when they kind of just begin. So I think that actually starting with optimization helped me out a lot. I think even though in some ways it's sort of antithetical to sort of the Bayesian approach, you know, sort of searching a parameter space for kind of the answer, right? The correct parameter values is not sort of what is done, but I think understanding that process and understanding the idea that you are sort of you know, sort of meandering around a surface, right? And that you're trying to find sort of a minimum or a maximum. And when the optimization process goes awry, you understand certain things about the shape of that surface. I think that really set me up to sort of have a better understanding of when you kind of just ask for inference for samples to be drawn, what might be going on behind the scenes, which of course helps when things are not going so smoothly. And so, I often describe for people who have this background in optimization or maximum likelihood estimation or something in that vicinity, I often just describe Bayesian inference, or the process, the actual sort of practice of Bayesian inference, as just kind of generating a random parameter value, right? Just doesn't matter for each of your model parameters, pumping that through your model, sort of seeing what comes out the other side, comparing it to your data. It's not going to be a perfect match because models are always wrong, but you can sort of perhaps say how good or how close it is to the actual observed data. And now just do that again, and do it again, and do it again, right? Do it thousands of times. And once you're done with that, now you have sort of a whole pile of samples, and you can use the sort of comparison between what your model generated under each of those samples and your observed data. And if you kind of weight those samples, those parameter values, by how good they kind of approximated your data, yeah, you're doing Bayesian inference at that point, right? So, and you're doing kind of an approximation of an approximation. You're doing what is sometimes called approximate Bayesian computation, but totally valid, and I think is much more intuitive. And then once you kind of get this sort of conceptual grasp of it, then you can forget about all that stuff and just kind of offload that to some black box function that is doing something that isn't really that, but is much more sophisticated, is much faster, is much more efficient. But I think having that sort of conceptual grasp helps, because I feel like a lot of people come to Bayesian statistics or data analysis with some understanding of kind of conventional statistics, linear models, logistic regression, t-tests, like whatever it happens to be. And then they kind of want to do the Bayesian sort of version of that. And then they sort of get stuck, right? Their model doesn't converge, or it doesn't start sampling, or there's some issue. And they don't know what to do because they've never encountered such problems when they did OLS. So I think having just a little bit of conceptual understanding about what is going on when you ask for kind of answers helps. And so that I think is one thing I've tried to pass on to people who might have a little bit of that background or some exposure to optimization or something.
I really like that, because oftentimes I feel like we're just overwhelming newcomers with like, oh, well, here's priors and posteriors and the model and like just all of that.
Yeah.
Whereas I think a lot of the benefit of Bayesian modeling comes not necessarily from the Bayesian, but from the modeling.
Yeah.
And it's true that you can build statistical models in other frameworks as well, but oftentimes people's first exposure to statistical modeling and that whole mindset is through Bayesian modeling. And that is like a great place to start, right? And you don't need to talk about priors and posteriors necessarily. You're just like, well, let's build this mechanistic model, the data generative process, and then just, well, how do we fit that to data? Well, optimization, everyone knows that.
Yep.
And once you have that sort of established, building it one step further with like, let's do that on multiple points. Yep. That's a really interesting approach.
I joked the other day because someone was sort of half complaining, half joking about sort of the kind of heft of the answers that you get out of the modeling process, this statistical modeling process, when you do things in a Bayesian way. And I said, why get a single answer when you can get thousands of answers? And on the one hand, that's kind of a joke, but it's also kind of exactly what is happening. Yeah. And so I think, to your earlier question, I think another thing that I like about talking to kind of relative beginners, either to the package or to Bayesian analyses in general, is I feel like people who have been sort of doing this for too long kind of forget, right? And so they're just throwing these terms out, MCMC, divergences, conjugate prior, like all this stuff. And so I feel like they can make the whole thing more complicated than it has to be very easily, and sort of without realizing it. And so I feel like one of the things I'm a bit sort of, I've had some practice at, is just being very sort of plain about everything, and be like, it's not complicated. Yeah, you get thousands of answers. These kinds of things I think yeah, gets people over, again, this sort of intimidation.
I see some of that teaching background from your academic career come through there. And the other thing which I think is interesting about that parallel, where you mostly spent your career in academia and used Bayesian modeling there, but now through your engagement with PyMC Labs, also have seen the industry application side of that. Was there anything there which you found interesting? Could be interesting because it's actually, oh, well, those are just really the same thing. Could also be interesting because, like, oh, that's actually quite different in how these things are applied in these different domains. Anything that comes to mind?
I mean, I think the sort of the obvious one is that oftentimes there is a very strong sort of emphasis on the ends in sort of these commercial applications, right, in industry. So, you know, there will be modeling, there will be choices about exactly how to put the model together. Should it be hierarchical or not? You know, what categories should we include? You know, these kinds of things. But in the end of the day, it's all about sort of what comes out the other end, and is it going to help us do what we need to do? And I think, which many people have talked about, you know, in a scientific context, a lot of times the whole sort of analytic phase is a bit ritualistic. It's a bit thoughtless. It's highly conventional. And it's being done because that's what you do. And so sort of this sort of keeping an eye on what exactly you're sort of getting out and is it useful, I think is sometimes overlooked. Obviously, if you're doing sort of things in a Bayesian way, chances are you are a little bit more focused on sort of, is this the right model? Is this exactly what I want to do? Does it match my beliefs? And is it sort of generating answers that I'm actually interested in? But yeah, I think that's sort of the major difference, is that people are very much treating this as a tool in business context because it is supposed to be helping them to do something. And so the details of that are not important if it is not sort of facilitating that mission. So yeah, and there is very much sort of a passion in sort of doing these things because people, you know, very much care about those ends. Yeah, which is sometimes refreshing.
Interesting. When you think about the project where it is today, and then I guess also with your specific community lens, where do you think the most improvements could or should come from in terms of innovation, or maybe just also governance, like how we basically make the tool even better? What do you think we should be focusing on?
Yeah, I mean, I think from a kind of user perspective, I think we're doing pretty well. I think we're doing well in part because the way that PyMC allows you to kind of describe and specify models is intuitive. It makes sense from a Python standard perspective. It makes sense from a statistical perspective, right? This is kind of what you would write if you're trying to write statistical models in Python. So, you know, in terms of the actual, you know, syntax and sort of state of the methods available and these kinds of things, I think we're doing pretty well. Obviously, every day there's sort of features coming down the line. I think the place to really focus future efforts is sort of awareness, and that isn't sort of PyMC specific. That is sort of awareness within the Python community, right? People who are doing data analysis, awareness within the statistical community. So, you know, the things I was talking about before in terms of intimidation and lack of awareness about sort of Bayesian approaches to data analysis, I think end up sort of shaping who shows up to sort of ask questions or download PyMC in the first place. Because if you don't know about sort of Bayesian approaches to data analysis, chances are you're not going to find your way to PyMC or any other Bayesian package. So yeah, I think from that perspective, I think the sort of community and sort of events that foster community and bring new users in, raise awareness in adjacent communities, I think is a place where we can certainly continue to expend effort because new users and awareness are only going to kind of bring people into the fold, and those new users, those new community members will help draw new community members, will contribute to the package, help answering questions, all these kinds of things. So you kind of get this multiplier effect, I think, when people hop on, that encourages more to hop on and sort of snowballs from there. So of course I'm biased because I am part of the community team and see sort of the community-facing actions quite a lot. But yeah, those sorts of things, the sprints, the sort of outward-facing events, I think is, one way that we can really get the word out, essentially.
Well, on behalf of all the Discourse users that ask questions and come to office hours, thank you so much for your work and also for chatting with us today.
No problem. Thank you very much.
Thank you.